Okay, so right here for number 11, you want to graph this shape, both of them. The ABC shape, that would be the pre-image, and then ABC prime, that would be the image. When you graph it, a lot of you haven't graphed it yet. Okay, then I'll graph it with you. I have it already graphed, but it looks like a lot of you don't have it graphed yet. So, let me zoom in. I'm going to use two different colors too. So the original, the pre-image is at, A is at -5, 0, 1, 2, 3, 5. So we got A. B is at -3, 1, 2, 3, 4, 5. B. And C is at -1, 2. So the original is called a pre-image. And then it undergoes some type of transformation, one that we're trying to determine. And the new points are at 1, 0. So this would be A prime, -1, 5. So we got B prime, and then -3, 2, C prime. And then we'll graph this shape. Then this new one is called the image. Okay, and it wants to know what type of transformation it underwent to get to this location. So kind of a weird situation here, but if you look carefully, it's actually reflected over this line right here. And this line hits at x equals -2. So the equation for this line is x equals -2. And so our answer for number 11, describe the transformation that maps this onto these points. It would be a reflection over the line x equals -2. Makes sense. Okay. Continuing on with the next one, number 12. This one they did the graphing for us, which is nice. They said, which best describes a possible step that is used to determine the location of the image of point B when it's reflected over the line y equals x. So we're specifically looking at point B right here. The line y equals x, they drew it for us, which is nice, and they labeled it. If we were reflecting this point over the line, it would be the same distance from the line, same direction on the other side. So it would land right here. So it's like one diagonal away. So then this would be B prime. And it asks which directions would describe this location. So we're just going to go through each step and see which one describes. Move down 1 and right 1 from 0, 0. That would be accurate. Move down 1 and right 1 from -1, 1. No, that would just put us at the line. Move right 2 from 1, 1. No, that doesn't make sense. Move down 2 from, no, that doesn't make sense. So it's just A. Okay, next it says point F is at -9, 6 is reflected so that its image is located at 6, -9. Describe the transformation using coordinates. So our original is at -9, 6, and then it undergoes a transformation and it's at 6, -9. So these would be our original x, y, and it wants to know how those are changing to get this. Well, it looks like this y is now in the x spot, so we'll put that there, and then this is now in this position. And that's what it's looking for, so this would be the answer here. Okay, next it says describe the translation. So translation is a slide from one location to the other. That maps A, which is -2, 7, to A prime 6, 4. So we're looking at what they're like adding and subtracting to the x and y values. So here to go from -2 to 6, that would be +8. And then from 7 to 4, that would be -3. So y -3. So this is the translation rule here. So that's what I'm looking for. And it is right here. Okay, and up here, number 15. Refer to the graph. Explain why a translation does not map triangle ABC onto EFG. Okay, well, real simply, like, they aren't congruent. The shapes are not congruent. You can't map one onto the other if they aren't congruent to begin with. Okay. Next, which is the image P, -5, 1 along the vector 3, -8? So the vector, what that means is this, it's like x plus 3 and then y minus 8. So we're going to just use that to translate this shape. So we're starting with -5, 11, and then we'll do the x plus 3, y minus 8, and p prime. So -5 plus 3 would be -2, and 11 minus 8 would be +3. So this is our new coordinates, and it would be D. Okay, 17. It says Juan is designing a new playground for the elementary school. He needs to determine the shortest distance from the monkey bars to the slide to create a path. Which statement best describes the translation from the monkey bars to the slide? This direction is important, so monkey bars to slide would be from here to here. However, we can't just say like diagonal. Instead, what we do is we say, okay, left, however many units, it looks like left 3, down 1, 2, 3, 4, 5, 6, 7. Down 7. And looking at this, so we're going to translate left 3, down 7. Okay, so now we're going to switch over to like the back portion. So I'm going to end this recording here.